Several analytical procedures allow refiners to assess asphaltene instability when mixing crudes. According to representatives at a past American fuel and petrochemical manufacturers Q&A session, even though these tests do have their shortcomings, refiners are more likely to face problems if they do not perform any tests. Most tests involve titrating the crude with a non-solvent either by hand or automated process and detecting flocculation either by human eye or using laser transmittance or near-infrared spectroscopy. Bill Iwood of Crude Monitor offers the Blend Compatibility Calculator to determine the compatibility of blending a crude in a diluent. On the website crudemonitor.ca, you can find the Blending Compatibility Calculator tool. To calculate compatibility between a crude and diluent, just enter the blending solubility numbers and insolubility numbers of the crude and the diluent, the percent in blend of the diluent, and the calculator will determine the compatibility as well as the solubility blending number and insolubility number of the resultant blend. To determine blending compatibility, Dr. Irvie requires the resulting p-value, which is equal to the ratio of solubility blending number to insolubility number, of the blend to be equal or greater than 1.3. This calculator requires a more conservative p-value of greater than 2.0. As such, the optimal percentage of diluent in the blend is calculated as that which gives a p-value of exactly 2.0. Crude Monitor's Blending Compatibility Calculator and Crude Density Calculator are available online for refiners for reference. Disclaimer: these calculators have been provided as a tool, and should be used solely for informational purposes. They are not intended to replace your own calculations as each situation requires specialized considerations. Crude Quality Incorporated accepts no responsibility for any inconsistencies with the actual chemistry that may arise from the use of these calculators. The Canadian Crude Quality Technical Association or CCQTA initiated a project to develop a new manual oil compatibility test method that would be different from the existing manual methods, where the details of which are not publicly available, and make it available to the petroleum industry. In this new method, excess amount of heptane is added to 3 different concentrations of a test oil to precipitate asphaltenes and subsequently enough toluene is added to dissolve the precipitated asphaltenes so that none is observed under microscope. From this data, a plot of flocculation ratio versus dilution ratio is made. This plot allows determination of all the solubility numbers including maximum flocculation and peptization power of the oil. The maximum flocculation is equal to the solubility blending number and the peptization power is equal to the insolubility number when toluene and N-heptane are used for both. Here is an example of a plot of flocculation ratio versus dilution ratio for Western Canadian Select made using the Canadian Crude Quality Technical Association's method. From the straight line obtained by plotting flocculation ratio versus dilution ratio, all the solubility numbers including maximum flocculation and peptization power of the oil are determined. The maximum flocculation and peptization power of the oil numbers determined by this method can be used for a number of applications. The peptization power of the oil to maximum flocculation ratio can be used to determine asphaltene stability and to control the process severity and prevent coke formation in the refining process. The 2 solubility parameters allow the calculation of the ratios at which the mixtures can be incompatible. Finally, the value of the peptization power of the oil is needed for diluents added to make bitumen suitable for pipeline transport. Most methods to test for compatibility determine solubility by titrating the crude with a non-solvent until asphaltene flocculation occurs. These commercially used tests can either be performed by hand or by automated procedure, and the flocculation is either detected by eye or near-infrared spectroscopy or laser transmittance. As flocculation increases, the light transmittance decreases. Spot tests, such as ASTM D4740 and a modified version of ASTM D4870 can also be used to determine the compatibility of a crude blend according to an ASTM manual called Crude Oils. Their sampling, analysis, and evaluation by Harry Giles and Clifford Mills. Spot tests require that a small sample of the blend be analyzed via paper chromatography. A ring around this spot indicates incompatibility. Additionally, for a crude that does not contain asphaltenes, the solubility number may be determined by blending the crude with a reference oil that does contain asphaltenes and then adding N-heptane until asphaltene precipitation occurs. ASTM D7112 and ASTM D7157 are two automated instrumental test methods that determine compatibility and stability.